All right, 10.6. We are still working on radicals, still working through different parts of it. 10.6 is fairly short. There's 6 objectives here, so it'll go pretty quick. And the first thing that we're doing in 10.6, still with the radicals, is the very first objective that we have here. Is it's not going to really ask you to do anything more than just to simplify. Now, and with this particular problem, though, that we're looking at for the first few here, that's in 10.6, almost everything that's in 10.6 is it's quotients. And when they're talking quotients, they're really saying fractions. I mean, that's really what it comes down to with this thing. Okay, and the very first one that they're going to have you do is something like this, where you have square root of 72 over 2. And with the simplifying, you're either going to be doing one of two things. You're either going to be doing the square root, or you're going to be dividing the two numbers. So if you start off with something like this, where you've got 72 divided by 2, you can think about that as being together. If they give you two separate parts. So you can do 72 divided by 2, make it the square root of 36. And then you go, well, square root of 36 is just 6. So in that case, that's as far as you want to take that thing down. Okay. They may give it to you where you have like square root of 30. I'm going to try that again. Hold on. Try that one more time here. Square root of 30 over square root of 15. Okay. And again, if they give them to you separately, you can think about them together, because if you take 30 divided by 15, that's the square root of 2. And for that one, square root of 2 doesn't simplify, so for that one, that would be as far as you would take that one. So when they're saying to simplify, really, you're doing two things. You're going to divide the numbers that you have that's possible. And then once you've divided those numbers, then you simplify the radical if you're able to. Sometimes you're able to, and sometimes you're not. And you may get some of these where when you break these numbers down, it may be that you're going to be left where you've got to take what's on the inside and break it down as much as you can. So you may get something like this, where you're going to take the square root of 40 and divide it by the square root of 5. So if you do 40 divided by 5, that would be square root of 8. But now, it's not a perfect square root, but you can simplify this one and break it down. So once you get it here, if you think about 8, that you can start breaking it up as 4 times 2. But there's your perfect square root of 4, so you can take that part and make it 2. And then your 2 is left on the inside, so that one would be 2 square root of 2. Okay, so on those problems, again, you're basically going to take the fraction, break it down, and then once you get it down to a number, simplify that number as much as you can. And again, it may be that you get a whole number, you may get something where there's nothing you can do, and then you may get a part where you can take this number and then break it down, just a little bit more as you go through those. Okay, objective number 2 is really, it's more of a quotient with a sum or difference. And this is almost one of those where it's like a halfway objectives, that they give you a problem where you're going to do a little bit of simplifying, but then at the same time, you may not do any simplifying at all. So they're kind of, it's almost like a halfway in between on these. One of the first ones that they may give to you. Maybe something like this, where instead of just being one number on top and one number on the bottom, like we had in the other example, this time you've got a plus or a minus. So basically you've got two terms in the numerator, and you've got the one term in the denominator. Okay, this one. With square root of 3, there's nothing you can do on this thing to simplify it. So all you can do on this one is there, and this is kind of where they're kind of going that halfway in between, that if you have this one, there's nothing you can do to simplify this. So what they want you to do is to break this thing, if you have two terms here over one denominator, you can take each term in the top and rewrite it so it's over the one denominator. So you can break the two-term numerator up so it's actually two totally separate terms. And then once you've broken it up, well, now you can simplify each part. If you've got negative 2 over 10, you can divide these both by 2. Make it negative 1/5. And on the last one, if you have 4 divided by 10, same thing here. You can divide these both by 2. To make it 2/5. So it'll be negative 1/5 and then plus 2 square root of 3 over 5. Okay, so they'll kind of use that one like a half step to say, all right, here's one where you're going to take this part that you have and simplify it, but you're not really simplifying the square root so much. It's more of simplifying the numbers that surround it just so you can kind of see how this thing goes and how it breaks it apart here. They're really getting you ready for some solving that we've got to do that's coming up in a couple sections down the road. So they're really more previewing you for that part that's coming up there. Let's give you one more of those just so you can kind of see that they may have some of these where you actually do have a square root that you could simplify. Okay, and again, you can still go ahead and break it up into two parts. You get square root of 45 over 3, and then you get 24 over 3. And with the 24 over 3, well, that's just 8. So we're good to go there. Now, with the square root of 45 over 3, that's where we can take this square root of 45 and break it down. If you start rewriting it, ever how you want to do it here, first thing I'm thinking is that it's 9 times 5. Well, if you do that, 9's a perfect square root. So you can take the square root of 9 and make that 3, and you've got 3 square root of 5. So with the first term, you get 3 square root of 5 over 3. 3's will cancel. And that would leave you with square root of 5 plus 8. Okay. And sometimes you'll get fractions. Sometimes everything cancels. You'll be left with whole numbers. It goes back and forth either way. It just depends on how it breaks out the number which goes through. Okay, so again, with number 2, some of these there's not a whole lot. It's really just breaking it up into two parts and then just simplifying each little fraction that's there. Okay, objective 3. This is where you're going to rationalize. And there's a couple of different ways they're going to have you do. The very first one on this one, when they give you the option to rationalize here, this one is going to be with a one-term denominator. And after we do a couple of these, then there's one objective we'll do in a minute where we do two-term denominators. And it's got a different way to look at it. But if it's a one-term denominator, you're going to do one simple little thing with this one. Okay, what they're going to ask you to do is you're going to multiply. Instead of just keep saying numerator, denominator, where it's going to go top and bottom because it's past it, you're going to multiply the top and the bottom by the radical in the denominator. Okay, now actually, I lied. There's one more thing to do after that. And that's pretty much the case with any radicals you do. You simplify if it's possible. 50-50 on whether it's going to simplify or not. Maybe, maybe not. It just kind of depends on the number. Okay, so for the first example, we're going to do 4 over the square root of 10. Okay, so if that's the problem you have, all you're going to do is, if it's a one-term denominator, just multiply both parts by whatever that denominator is. So if it's square root of 10 at the bottom, multiply both parts by square root of 10. Okay, and from there, just multiply it straight across. So you've got 4 square root of 10 on the top. There's nothing really you can do with that one just yet. On the bottom, though, if you do 10 times 10, that's 100. And the reason they'll have you do the same number times itself is that if you do 10 times 10, you get 100, but if you square root 100, you're just going to get a perfect 10 and back out of it, right? Okay, pull that back over here so we can see it a little bit better. And if you have 4 square root of 10 over 10, well, now you've got this number that's on the outside. You can simplify like we were doing a little bit earlier. You can divide these both by 2. So then you can make that 2 square root of 10 over 5. Okay, now, and honestly, that's probably one of the longer problems that you would do, as you're going through this one. Some of the shorter ones. Let's say it was square root of 3 over square root of 7. And again, directions will say rationalize, so it's usually pretty straightforward when you go through the directions on these. So all you're going to do is you're going to take that square root of 3, square root of 7, and you're going to multiply it by whatever that radical is that's in the denominator. So on the top, 3 times 7 is 21. Now, on the bottom, if you want to go ahead and shortcut it, we know that if we do 7 times 7, it's going to be 49. When you square root it, it's going to be 7. So for that one, if you want to just go ahead and say that it's going to be 7. And with the 21, there's no perfect squares you can take out of 21 because it's just 3 times 7. So there's nothing you can do to simplify that radical, and if there's nothing you can do to simplify that radical, then that's the answer that you have. Okay, objective number 4. Still the same thing. The only thing they do different on objective 4 is still going to say to rationalize. So they're not changing anything here. The only thing they do different with this one is they're going to give you something like this, where instead of it being 2 fractions separated, or square root on the top and square root on the bottom, now it's just the square root of 1 big fraction. So it's the square root of 7 over 21. Okay, and now it's kind of going back like we did before. If it's 7 over 21, you can divide them both by 7. So go ahead and just simplify the fraction first and make it square root of 1 over 3. And once you've simplified that fraction as much as you can, then you can go ahead and separate it into 2 parts. So it's like the other part. So now it's the square root of 1 over the square root of 3. The good news is, though, if you do square root of 1, that's just 1. Okay, and now that we're here, we'll kind of bring that one back over here. Now that we do that, now it looks just like the problems that we had back up here, that now that you've got 1 over square root of 3, you're going to take that number, and now you're going to multiply by the number that's in the denominator. So we're going to multiply the top and bottom by square root of 3. Here, on the top, 1 times the square root of 3 is just the square root of 3. On the bottom, if you do 3 times 3, it's 9. But again, if you take the square root of 9, that's going to be just a 3. Let's do one more of those. Square root of 5 over 7. Can't simplify, right? Nothing you can do on that one. So that one's one you can just break it up into 2 parts. Make it square root of 5 over square root of 7. And since there's no simplifying on that one, then all we're going to do is just take and then multiply by that denominator radical. So we've got 5 times 7 for 35 on the top. And again, on the bottom, we could do 7 times 7 and make it 49, but when you square root it, we're going to come back to the 7. And again, because there's nothing you can do to break this down, there's no perfect square roots that come out of that 35, that's just going to be the answer there. Okay. And if you're kind of wondering what, and I should have said this back here earlier, that when you rationalize, the whole big thing that when you rationalize, the whole thing you're trying to do with it is you're trying to, basically you're going to remove radicals from the denominator. Okay. And that's all that rationalize means. That way, and the whole purpose of it is that if you start adding and subtracting fractions, it's a lot easier to add and subtract fractions with whole numbers than it is if you got something with radicals, because it just makes you think in a whole different ballpark. So that's the whole point of rationalizing when you go through those. Honestly, this may be one of those things that in the next few years, if math people will let go of it, it may be one of those things that, you know, for some of the lower level classes, they may not have you do it because calculators will do all that for you. That's what most people say. Like, why do I need to know that? Well, it's, you know, you got to know what to do when it breaks down, right? When the zombie apocalypse happens, you got to know how to rationalize fractions. All right? Because somebody's got to keep the nuclear power plant from blowing up, right? Mm-hmm.
Shuts down and actually cools it off. It's like they melt down, use it too late, but nobody wants to get back to the wild.
Yeah. All right, objective number 5. One more rationalizing. The one difference on this one is up to this point, everything has been numbers. This one, they're going to throw some variables at you. Okay, now, the good thing is for this one, as long as we're doing square roots, it's still the same thing. It doesn't matter if there's a variable in there or not. You're still going to multiply by the exact same thing that you would have and just work it out from there. So let's go square root of z over the square root of 3. Right, good news on this one is there's nothing really different about this one, so you're still going to go ahead and multiply by square root of 3 over square root of 3. Okay, on the top makes it 3z. On the bottom again, if you do 3 times 3, it's 9. We square root it, we're back to the 3. So that would be the number we're looking for. And again, this one's inside the square root, so there's nothing you can do to cancel because you're only going to cancel what's on the outside. So that one would be the answer that we're looking for. Okay, now let's give you one where you actually get a variable in the denominator. Okay, if it's 9 over the square root of 2w. It doesn't matter, as long as it's a square root, it doesn't matter what you have in the square root, you're still going to take and multiply by that square root that you have in the denominator. Okay, again, on the bottom, now the only difference on the bottom is is if you do the same thing times itself, but when you square root it, you're going to come back and get the same thing. It's going to be a 2w, let's say. On the top, 9 times 2w. Kind of the same boat back here. This 2w is in the square root. This one's not. The only thing you possibly could simplify would be the 9 over 2, but that won't simplify. So that's as far as that one will go. Okay, so variable or not, still the same thing. You multiply by whatever's in the denominator, and if you do the same thing times itself but square root it, you're going to come back and just get whatever that term is. Variable or no variable, you're just going to get that expression back out of it there. Okay, and the last objective. This one you're going to rationalize, but it's 2 terms. Okay, when you rationalize 2-term denominator, it is one little thing different for this one. And what you have to do is you're going to have to multiply the top and the bottom. Now, because it's 2-term denominator, it's going to be a little different. It's not the exact same denominator, but you're going to multiply the top and bottom by the conjugate of the denominator. Okay, and I know probably everybody's going, what is the conjugate? Does anybody know what it is? All right. Just ask it. Sometimes you get somebody that maybe did. All right, here's how the conjugate is. You just change the plus or minus sign in the middle. So that's all you do for the conjugate. So if you want to think about it without square roots and all this stuff, that if you were given a plus b, and they said find the conjugate would just be a minus b. Now, and sometimes people get thrown off. They're like, well, what about, if the first number was negative? If it was negative 2 minus, if we go back to the complex numbers, if it was negative 2 minus 6i. Still don't worry about the first number. That one doesn't matter. It's this sign right here that you would change, so this would be negative 2 plus 6i. Okay, now here's the reason why you do that. And we'll back up to the a plus b and let's do this. We're going to give you one where it's like x minus 2. Okay, you had to find the conjugate. It's x plus 2. Here's why they talk about multiplying the conjugate on this one. What happens if you take these two things and do the full method? I think we did a problem like this last time. You remember what we did? If you there was a problem that may have been just kind of mixed in with something. But does anybody remember what happens if you multiply these two things together, where the only thing different is the plus and minus in the middle? We do x times x to get x squared, right? We do x times 2 to get 2x. We do negative 2 times x to get negative 2x. We do negative 2 times 2 to get negative 4. What happens to the o and the I terms? Cancel each other out, right? So this whole thing in here is gone. That's going to leave you with the first number times itself and the last number times itself. So you're going to be left with x squared minus 4. So that if we do that with the square roots and multiply the conjugate, the square roots go away and you're left with just whole numbers. So that's why they had you go back and do this whole conjugate thing on this. You do that with, I don't think we ever did that with the rational numbers, but that would have been, with the imaginary numbers. But if we had division with imaginary numbers, we would have done the same thing. We would have used the conjugate. Okay, so here's what the problems will look like. They'll give you a problem like this, and they'll say, all right, rationalize. Okay, so all we're going to do again is take that exact same problem, but when you multiply this time, you're going to multiply by 3 square root of 5 instead of plus 2 to make it minus 2. And whatever you do on the bottom, got to do the same thing on the top. Okay. Now on this one, here's one where, for most of these problems, hang on to that -5 for just a minute. Because basically it would be this. Don't go ahead, don't multiply it out just yet. Hold on to it for just a second, because we really want to key on the bottom part. That's the main thing we're going to do. And again, technically we're supposed to do the full method, but if these two things are conjugates, we're not going to do that. We're just going to do the first times the first, and then we'll do the last times the last. So we're going to do 3 square root of 5 times 3 square root of 5. Because we got to be a little bit careful, because you do 3 times 3 for 9. When you do the 5 times 5, that is 25. Okay, we're not going to worry about the O's and the I's in the middle. That's going to go away. We're just going to do positive 2 times negative 2. Make that a negative 4. Okay, but when you do 9 times, the square root of 25 is just 5. So that's 9 times 5, that's 45 minus 4. So on the bottom, that's going to come out to be a 41. Okay, now here's why I wanted you to kind of hang on to that one for just a minute. Because sometimes, depending on what this bottom number is, if this thing had been 40, let's say for just a second, then you could cancel the 5 and the 40 and make it just, -1/8 for that part. Then you could do that with it. But since this one doesn't cancel, that's just 41, they might let you leave it like this, but they're probably going to make you go ahead and do distributive property on this top part. -5 times -2, that would be a positive 10. And that's one of those problems where sometimes it's kind of iffy, because if you do distributive property and then this number comes out to be 40, you could simplify them out, and it's kind of 50-50 on how to do that. So it's usually one of those where if you do distributive property, you're going to have to factor it out, where if you don't do distributive property, you won't. So either way you go, you're probably going to have to do a little bit more work than what you want to do. And there's really no good way of knowing it until you get the numbers. If it's something like 40, and it might be better to do the number on the bottom. If it's 41, then you might can see it. So maybe we'll do that on the next one that we do here. Okay, so with this one, let's do 7 over 3 square root of 2 minus 1. Right, and again, for this one, all we're going to do is we're going to multiply by 3 square root of 2 plus 1. Just making sure we change that sign. Alright, and again, on the bottom, we're going to do the full method, but with the full method, this part, the O and I are going to knock each other out. So we're going to do 3 square root of 2 times 3 square root of 2, which again is going to make that 9 square root of 4 minus 1. So square root of 4 is 2, so this is really 9 times 2. So that's 18 minus 1, which means the bottom is going to be 17. Okay, now, and again, it may be better to go ahead and do the bottom part first on this one. Just thinking back on this one. Because now, if we're going to do distributive property with the 7, if you could simplify this 7 and that 17, you would go ahead and simplify that part, because basically here we have 7. We'd have 7 times 3 square root of 2 plus 1. But since the 7 and the 17 will cancel, there's nothing we do to simplify that one, so they're going to probably make you go ahead and do distributive property. So 7 times 3 would be 21 square root of 2, and do 7 times 1 to make it 7. Okay, so that may be the better bet. Go ahead and simplify the bottom part, and then if you can simplify, this number and that denominator, go ahead and do that. If you're not able to, then you're just going to have to go ahead and do distributive property.